Dr. B, thank you for joining me during these times. I mean, everybody is busy and stuff with Zoom interviews, so really matters. Thank you.
Yeah, you're welcome. And I've said it on Facebook, but now I get to say it in person. So insofar as much as this is in person these days, congratulations to you, Dr. Shafiq.
Thank you.
On completing your PhD.
Thank you so much, Dr. B. And I heard from multiple sources because I never got a chance to get a course from you. So many people have told me how amazing you are, especially in the classroom, the way you organize things, the way you execute things. So great going, sir.
Thank you.
Okay, tell me a little about the background you have there. This is beautiful.
Oh yeah, so this is a town in Italy. It's called Aronso di Cadore. It's about 2 hours north of Venice, and just on the other side of the mountains, more or less, is Austria. So it's in the very northeastern part of Italy. It's the town that's my grandmother's ancestral home. Both of my grandparents on my mom's side came from Italy. My grandfather's town is awesome too. It's just not scenically as beautiful as this one. So this makes a nice picture, and it's a good reminder of places that we would like to travel once we're allowed to do things like that again.
No, this seriously is very beautiful. And how about you begin with your story a little? I mean, of course, we cannot go for the complete biography, but
yeah,
just tell a little about how you came into construction management, starting from your grandfather, let's say.
Yeah, absolutely. So I grew up in a home with my grandparents in a two-family home in New York City in the Bronx that my grandfather built. He was a carpenter, and as a kid, I played around with him. He had a wood shop in our garage, and so I mean, like a lot of little kids, right? We aspire to be like a parent or an aunt or an uncle or a grandparent, and so I spent a lot of time sort of glued to his hip, wanting to learn how to do all these different things that he could do. And when it came time to think about going to college, going to school, I then decided, I should go in a completely different direction. And I dabbled in some other things. I have some degrees. I have a political science degree. I have an environmental science degree. I have a forestry degree. Because I really thought that was the role that I was going to play was going to be like an attorney or a policy person involved with the environment. And just through circumstances, I ended up working back in construction after I got my master's degree. So I was at one point in time, I was a construction superintendent, a field superintendent with an Ivy League master's degree in forest science, which made for good conversation at times. And it was really when I then got back to working in construction that I realized, this is really the path that I should be following. And then I just had the opportunity to come to MSU and do a PhD in construction management and sort of round out my education, because I had no formal education in construction and engineering. I mean, I was working as a superintendent. I became a project manager. I was doing the work, but I never had a scheduling class. I just did scheduling. And so I had the opportunity to come to MSU because I knew, regardless of whatever my life path was, teaching, researching, sort of being part of forming future generations of people in this industry was really what I wanted to do. So it was a mid-career change. I got my PhD when I was 39. So yeah, it was definitely a mid-career change, but it's been good. I've been doing this now for 5 years as a professor at MSU, and I think it was a great career change.
And you're doing great. I think it worked out perfectly, and it was a good thing you made that change. And you know what? Whenever I listen to stories like yours, I always compare them with the ecosystem back home, because such changes are not possible, or perhaps mentally not acceptable to people
right.
back home. So you always listen to these stories like he thought his passion was this. Like the word passion perhaps doesn't exist for us. So definitely something we as a society need to work back home.
No, and I think it's globally. In some ways it's an issue, because even if I think about Europe, I think about Italy, I think about Spain. I have some professional and personal connections back in Spain. It's the same story there. Kids get pigeonholed in about middle school into if they're going to follow a university track or a technical school track, and even what their specific career will be. And it's really hard to change that after middle school. And I ask you, what 12 or 13-year-old kid really truly knows what their life will bring them. So I value the fact that our society is a little more open, maybe in that way.
Yeah, definitely. So Dr. B, there are a gazillion topics that you can talk. I know that, and you're very expressive and very eloquent. That's one of the reasons I wanted to talk to you. But you keep on talking about this terminology, and though I have tried to learn a little, but I still am a long way to go. And I wanted to do this personally anyway, so I thought, why not do it here and share it with everybody? The word is domicology. Did I pronounce it correctly?
Yeah, domicology. Yeah, absolutely.
Domicology. And suddenly it's the buzzword I keep on hearing, not but other sources as well. And it looks impressive because it has something to do with sustainability as well, right?
Yeah.
So how about you just take the floor and tell us about domicology?
Sure. And I'm gonna tell you the story the way I've been telling it to people more and more probably in the last year. If you go back to the 1830s or the 1840s, you had biological scientists that were studying all manner of animal and ecosystem interactions. You had food web biologists that were worried about how energy cycles through food webs. You had biologists that were worried about animal habitat and how competition for habitat resources drives behavior in animal populations, and on and on and on. Sometime in the 1850s, these fields sort of came together around the notion of ecology. And all ecology really is understanding those dynamics of animal populations and smaller groups as well around food, basically around habitat, food, energy cycling, nutrient cycling, all of those pieces. So ecology existed, the science that underpins ecology existed before the term. Much in the same way, the science that underpins domicology existed before we coined the term at MSU. So before we coined the term, you had urban planners that were concerned with policy solutions to blight. You had construction managers that were concerned about the costs of demolition and the costs of deconstructing buildings. You had workforce people that were concerned about the safety training requirements for people that were involved in taking buildings down. But what you didn't have was you didn't have a way to speak to the interaction among all of these disparate groups of people. Where if you believe that all of these folks were working toward some idea of a possibly unified end state, which was a better built environment, we just didn't have a way to talk about it in an integrated fashion. So what domicology says at its core is that when we build buildings, we should build them with their end of life in mind. And when we think about buildings at the end of their functional lives, whatever takes them to that point, we should think more holistically and more broadly about what we do with those buildings. So, of course, the first preference would always be, can we adaptively reuse a building? That's, we take advantage of maintaining the energy and the carbon that's locked up inside of those buildings by repurposing them. But if repurposing them is not possible, our next goal is how can we dismantle them in such a way where the materials can be extracted in a more reasonable way, and then those materials can go into some productive end use. But just the same way, we've got urban planners and policy folks that are working on the front end to say, how can we better manage buildings at the end of their lives? So currently, the way things tend to happen, a building goes through its use, it reaches the end of its useful life for some reason. And if nobody is around to do anything productively with that structure once it reaches the end of its life, it typically falls into abandonment and disrepair. And then it's up to the local unit of government that controls the land where that building is sited to do something about it. So it means taxpayers, you, me, everybody else, we end up paying to sort of fix that problem at the end of its useful life. So what dome ecology suggests is that we should be looking at policy tools, at market tools, at technology tools that can help us promote a better end of life for buildings. One of the things that we can do immediately, and I'm not going to name names because I don't know who would see this video, but there's a building very close to MSU's campus that the entire building is being made of light gauge steel prefabricated wall panels, which means that every wall in the building is load bearing. There is not a single non-load bearing wall in this structure. So it's great because from a construction perspective, it goes up fast. We're using these modular, lightweight panels that can be craned into place. The building goes up fast. But what it means is that 20 years from now, if the current use of that building is no longer desired, if there's no longer a market for that use of the building, that building will be virtually impossible to retrofit into a new use because the cost involved and the effort involved in moving all of those load-bearing walls will be really will price that option away. And so the most expedient option to deal with that building, if consumer preference says that the current use of that building is no longer desired, will be to demolish it and build new.
Ooh.
So dome ecology says not only should we think about how to harvest more material and really think about buildings as part of this notion of the circular economy, we also say at the beginning of a building's life, you should consider these circular economy implications just by not designing and not building something that has so few options if and when it reaches the end of its life. Does that all make sense?
It does. It definitely does, and it's supposed to be common sense, but right. I mean, it's supposed to be there if you're talking about the life cycle, but definitely at the beginning of the project, the client's mindset is not ready to have a temporal positioning which is so ahead in future.
Correct.
So it's more about educating people about it, and yeah, I heard this phrase from Dr. Abbasi, who's a psychiatrist here, is that you don't preserve what you don't love, and you don't love what you don't know. So first they need to know.
There you go.
Or they come to this. So
well, and I think part of it, it's no fault of anyone specifically. What do they say? There's errors of commission and there's errors of omission. I think these things fall into the errors of omission. No one is overtly, I don't think, out there saying, oh man, let's design a built environment that's going to be useless in 20 or 30 or 40 years. No one is doing that. But when you look at, like sort of the typical development cycle of a building with a private owner, private owners wish to extract their value from a building on relatively short time spans.
True.
Buildings can exist long beyond those financial return time spans, right? I mean, buildings, go to Northern Europe, I'm sure, go to Pakistan, you've got buildings that have stood for hundreds, if not thousands of years. So I don't think anybody, no one is sitting in a smoke-filled room saying, oh man, how can we mess up the built environment today? It's just to your point, we don't love what we don't understand. And so if we only see things through the lens of profit, how quickly can we profit? I think we just don't see some of these other sides of the equation.
Wonderful. So what is the research in this area like? What are some of the things you work on?
Yeah, that's a great question. So the research in this field is really sort of all over the place, and it's driven largely by the people that make up the research team. So again, we've got workforce development researchers, we've got urban planners, we've got engineers, we've got folks from construction management, and we're all asking questions that are, I think relevant to our domain. So within construction management, we're asking questions about things like time and cost to deconstruct a building versus demolish it. So how much extra does it cost? How much time does it take to bring a building down in a more manual fashion so that more material can be salvaged? I'm now in the process of putting some research together that asks questions about what does the carbon and air emissions budget look like for deconstructing a building versus demolishing a building, because we believe that there may be public health implications when you demolish, because you're making, it's a more mechanical process, so there's more likelihood of materials to become airborne. So asbestos, lead, even just general particulate matter. And then there's a question about when that material goes airborne, what does that do to the health of people that are living around those sites? And the reality is, while there's abandonment everywhere, every community has examples of abandonment. Abandonment tends to be concentrated in municipalities and cities that have a long history of economic disinvestment. So you're talking about residents that are at or below the poverty line, whose health may not be great as it is as a result of sort of their socioeconomic status. So we're interested in looking at this public policy idea, and this is what I think is cool. Construction managers doing research, talking about public policy related to health, because our concern is if manual removal of buildings has a positive impact by not emitting as much dust into the air, is there the potential to make a public policy argument that says that cities should invest more in deconstruction, which is more costly than demolition? Because if you invest the money today, you're not paying in 20 years for the kid that has elevated lead levels in their blood. The adult who's asthmatic, whose asthma is being triggered because of these dust clouds that are being generated through demolition activity. So we're sort of interested in maybe juxtaposing elements of this argument and saying, if we better understand what the emissions look like, maybe we can start to make some connections with public health. We're also interested in the emissions question from a pure carbon perspective. Is the process of deconstruction, while everyone that we talk to thinks that it's more environmentally friendly, does the process of deconstruction account for more atmospheric carbon? Because it's a more manual process. More vehicles are involved. Vehicles are going to different places, often greater distances, to salvage material rather than just haul material to the dump, which the dump, the landfill is usually closer by. So we're trying to understand what the carbon budget of these processes look like, to then say, do we need to look at process improvement? Are there ways to improve processes? Part of the process improvement angle that we've been looking at, I've got some folks that for the last couple of years have been working on, we've been looking at robotic technology, and could we involve robotic technology to make the process more efficient? And if we can make it more efficient, does that then have an impact on carbon and emissions and setting markets and impacting supply chains and pieces like that? So it's really, what I hope I'm getting across is that dome ecology is really more than interdisciplinary. It's really a transdisciplinary endeavor, and we can really ask, I think, some very interesting questions that don't confine us to what department are we in, what college are we in, we can really start to think bigger.
Wonderful. So I do have one more thing I want you to talk about, but that might be a little deviation. Maybe it's not. I mean, wood as material is more sustainable, right? And I never realized that when I was back home, because we didn't have wood construction.
Right.
there are some northern areas where there's a lot of wood, so they construct with wood. But we always thought that wood is, we don't need to cut trees because cutting trees and making homes is cruel. You're destroying nature.
Yeah,
But
yeah.
well, it's only when I came here that I realized that wood is something that can be generated again. And if you keep that balance, it's actually a sustainable resource as compared to steel and bricks and all those other building materials that we use. So tell us a little about wood
Yep.
and what are some of the advancements in wood? I keep on hearing about this mass timber material. So what is that?
And this is great because I can connect this directly to dome ecology. It's the other, really, it's the other side of my primary research agenda that I've got. You know, I'll let the forest management and forest ecology folks talk about why sustainably managed forests actually perform better from the perspective of carbon sequestration than non-managed forests. So we'll just, for right now, if we can just agree that the concept of a sustainably managed forest, which means some extraction for timber, is okay, we'll go to the next piece, which is, as you alluded to, wood construction in the US is sort of our traditional norm, our traditional mode of construction, at least in residential and smaller commercial buildings. But there's an advancement that's been made over the last 20 or 30 years, starting in parts of the US, parts of Northern Europe, in mass timber. And really all mass timber is now taking wood and adhesives, making large cross-sectional area pieces of timber building material to mimic what we could have done 200 or 300 or 400 years ago when we could have had large cross-sectional area solid timbers, right? So when we had larger, older trees, it was a lot easier to get a large cross-sectional area solid sawn piece of timber. A lot more difficult to get that nowadays. We harvest trees at younger ages for the timber industry. Our standing stock, while we have more trees today than we had even 20 years ago, diameters tend to be smaller than what they were a couple of hundred years ago. So now we get to those same large cross-sectional areas by making layers of wood and adhesive resins to mimic that method. So we've done glue laminated timber in the United States for well over 80 years. And now we're starting to get into using more cross-laminated timber, which is something that was developed in Austria, Germany in the early 90s. We're now starting to get interested in it in the US. And I think there's going to be a lot of drive to do more of these projects in the US because the International Building Code, the 2021 version of the IBC, is changing to allow us to build with mass timber up to 18 stories.
Wow.
So currently by code, you can build 4 stories in mass timber. There are taller buildings than that in the US, but they had to get code exceptions, or they had to have special codes adopted to allow it. Starting in 2021, the base code that's really the base code for the vast majority of the United States, the IBC, will allow up to 18 stories of mass timber. So, you know, now you're talking about buildings that have the ability to sequester major amounts of atmospheric carbon, biogenic carbon, as opposed to doing a building in steel or concrete where just the manufacture of those materials generates a significant amount of atmospheric carbon, right? Just through the burning of fossil fuels to make steel and to make concrete. So now we're starting to think about buildings not only as being carbon neutral, but maybe carbon positive, in that the material itself can sequester more carbon than the process emitted to make it. The tie-in to dome ecology is that wood is a material that when buildings get demolished, it's really difficult to reuse wood. So a lot of it ends up in the landfill. So we have a study going right now to look at, can reclaimed lumber be used to make glue laminated timber and cross laminated timber, predominantly those two products. So we have an interest in seeing how those materials behave to make these laminated systems of structural timber. We have a little bit of work in general on mass timber going on at MSU. You know, we have a mass timber building under construction on campus, the first one in Michigan. I just graduated a master's student who put together a predictive cost model for building mass timber buildings. So as an aid to the architecture, engineering, and construction industry during the conceptualization phase of buildings, to just have an opportunity to look at what those costs might be to do mass timber, because we have really robust and well-developed estimating tools for concrete and steel, but such a tool didn't exist for mass timber until Bhushan finished his master's and produced that tool. So we're doing some work in that space related to cost, time, process change, but then we're doing the bridge work with Dome Ecology to understand how to manufacture these products with salvaged wood.
Wonderful. They are all amazing areas, Dr. B. Seriously, I mean, I claim to be interested in sustainability, and this was inspiring, seriously. And
thank you.
I wish you all the best with all the projects you're working on, and I really hope to see you personally before I leave. I mean, it's been crazy for a couple of months now, actually.
Yeah, I know. It feels like, sometimes it feels like it's been 2 years, and sometimes it feels like it's been 2 days. But yeah, it's right. I think it was March 11th that we switched to online.
Yep.
And today is May 10th. So yeah, 2 months.
2 months. You know, I almost every day I ask Rabia, what day is it? Like, it's
yeah, yeah.
What day is it?
Yeah.
It's crazy.
Yeah, we've sort of lost our external clock on these things, right? Yeah. It is crazy. I really hope I get to see you before you head back to Pakistan, and we may just have to violate social distance for the sake of seeing you before you go.
But I hope we celebrate properly, and I will see you then, Dr. B. Thank you so much for your time.
Thank you, Faizan. I really appreciate your interest in doing this. Thanks so much.
Have a wonderful rest of your day. Bye-bye.
You too. Take care.